Hey everyone, welcome back to another video. In this one, we're going to be configuring network address translation in three different ways: static, dynamic, and then dynamic with overload. So let's get started. We're going to hop onto R1 here, and first and foremost, we're going to start with the static NAT method. So this is commonly implemented on web servers and any other servers that you are pushing content out into the public internet. And yeah, so we're going to assign this one. It's essentially assigning the server a public IP, but any traffic it's sending out this way, it's going to translate from this network to the public IP address of this range right here. So let's configure that. We're going to hop into global configuration mode, and then we're going to configure our NAT. First and foremost, we want to make sure that our interfaces, our individual interfaces, are configured with the IP NAT inside or IP NAT outside commands. Those commands will basically tell the router when to translate the address. So this interface is within our inside network, so we're going to configure that one as IPNAT inside. So let's do that. And then this is spacing out to our internet and public network, so we're going to do an IPNAT outside for that one. 0/0. Okay, so that is configured. Now we have to enter a command in order to NAT this address. So we were assigned range right here, 203.0.113.0/28. Those are the list of public IP addresses that were made available to us through our ISP. And we're just going to use one of those to statically assign it to our web server inside our network right here. Oops, there we go. All right, so we use IPNAT inside source, and then we're specifying our inside source, which is a static IP. And from there, we type the address of the web server, or also referred to as the inside local. You'll see that in a second. And then the public IP that we want to use for it, which is 203.0.113.3, and press enter. And that should automatically translate any outgoing traffic on this interface from this address to that one. So let's verify that. We're going to make sure that it can ping our external server out here. So let's go to command prompt on this server, and then ping that address, 203.0.113.20. All right. And this will just take a second to reply. We should get a reply though. In the meantime, we're actually going to open up the web browser on this server and just be prepared to test out the public IP of this web server right here. Make sure that web page is pulling up when we're using the NATed address of 203.113.3. As you can see, we got a reply back, so this should work as well. And there you go. There's our web page. Not the fanciest of websites, but you know, it'll do for this. And let's close out of this. So our static NAT is successfully assigned. It's working. But just there's one command I want to show you in case you're like troubleshooting or you just want to see what your NAT is doing. So let's get out of global config and type show IP NAT translations. And this will show you all of the network address translation. So there's our ICMP traffic for our ping. So inside global is just the public IP that you assigned for your outside interface. And then this is the NATed address for the inside interface. These two will almost always be exactly the same, the outside local and outside global. 2A NAT, it could be like a little different, but that's a whole other thing that we don't have time to explain. So there you have it. That is just checking out the NATed addresses with the show IP NAT translations command. And next up, we're going to want to use network address translation for our client devices over here. And if you haven't noticed already, network address translation is very important to protecting any sort of special information inside your network, because we're not using the actual IP addresses of the clients. They're disguised through the translation itself. So we're going to use dynamic NAT for this one, just so we can, use a range of public IP addresses that can be used for translation instead of just one. That way we can have more client devices being able to reach the internet with those translated addresses. So let's hop in the global configuration mode again. And then we are going to do this a little bit differently. For dynamic NAT, we are going to want to assign a pool of network address translation addresses. So we can use that with the IP NAT pool command. And then from here, you specify the range of addresses that you want to use for that pool. So we were assigned up to .12 in that 203.0.113 network. So we'll use the one after the .3 that we just used, so .4, all the way to 203.0.113.12. And actually, before I do anything else, we want to assign a name to this pool as well. This will come in handy later. You shall see soon. Okay, so we're just going to assign it the name of client. So IP NAT pool, and then the name of your pool, and then the range of your addresses. And then you want to specify the subnet mask. So for this one, it's a /28. So the subnet mask for that is 255.255.255.240. All right, so our NAT pool is configured. Next, we want to create a ACL that permits traffic for this entire 10.0.2.0/24 network. That way we can use it as our inside source. So this network address translation can know which IP addresses it's going to translate for. So we're going to do a standard access control list with the access list 1, and then we're going to permit traffic for the 10.0.2.0/24 network. Oh, a wildcard mask for ACLs. 0.0.0.255. Okay, so we have that. Now, the last thing that we want to do, well, actually, it's the second to last thing we want to do, is create the configuration. So we're going to do IP NAT inside source, and then our inside source is access list. So in order to specify that, we do list, and then the name or the number of the list. And then we're going to specify your pool. So type pool and the name of the pool, which is client. Oh, I had a typo there. Okay, so that is set up. However, we forgot to do one thing before we did any of this, and that was to specify this interface right here as a network address translation inside. So we're going to go into interface configuration mode for that one, and then IP NAT inside. Okay. So we're looking pretty good on the dynamic NAT, at least on paper. Let's check it out. We're going to hop onto these client devices to generate some traffic so we can get some translations into our table. And we'll see if it does well. So let's ping the external server 10.0.113.20. We give that a second, hop on PC2 here, do the same thing. Should be All right, cool. So we can actually reach that, which is great. And then, yeah, once we hop onto R1, again, we are going to use the show IP NAT translations command again. And then you can see the inside local, inside global addresses, all that good stuff. So I show IP NAT translation. All right, cool. So there's our ping traffic. So this is our PC1. So as you can see, it was using the .4 address in our pool. And then this was PC2, our inside local, and it was using the .5 addresses in our pool. So this is great. It's a little more, flexible in comparison to static network address translation. However, this is limited. The amount of internet connections you can make with client devices is limited to the amount of addresses in your NAT pool. So in order to avoid any like congestion or any dropped packets, make sure everybody is getting access to the internet through this network address translation, we need to configure dynamic NAT with overload. It uses port address translation, which when it generates connection, it will use, hold on, looks like packet tracer just stopped for no reason. Let me pause and come back here. I'll be right back. All right, so we're back. All right, where was I? So before I was so rudely interrupted by our software, I was talking about port address translation. So pretty much it uses the same public IP address for every connection, and each connection is allowed out to the internet via each client device, because what it does is it will use a different port for each individual connection so that it can have that multitude of connections using the same IP address. So what we're going to do here now is actually we're going to configure this F00 interface with a DHCP address, which is going to be provided from this range right here, the range of public IPs that we've been using. So specified my NAT inside on this interface, specified my NAT outside on this one. So next thing we want to do, we actually want to hop back into F00 and get rid of the IP address. So no IP, and then we're going to do, hold on here, one moment. Yeah, we're going to do an IP address, DHCP. And this will automatically make that interface a DHCP client, and will automatically apply a IP for that interface. Okay, so as you can see, it automatically assigned to 203.0.113.13 with the /28 mask. All right, so we're good there. Now what we actually want to do is in our NAT configuration, we're going to use, we're going to do the list just like we did with dynamic NAT for the 10.0.2.0/24 network. So we're going to create a list. The other one got deleted because packet tracer quit. So access list permit 10.0.2.0, and then the wildcard mask /24. Okay, so we have our list set. Now, instead of specifying a pool with the name and the IP NAT inside source command, we're going to use the interface right here that is using that one specific IP that was assigned through our DHCP server. So we got IP NAT inside source, our access list, which was 1, and then int, or interface, short for interface, F00. And press enter. And actually, we forgot the most important thing. We want to do it with overload. So that is the last thing that's very important. That's going to initiate the port address translation and allow that IP address to be reused for every client connection we got going on out to the internet. Okay, so that is configured now. And then let's check it out and see what's going on with that port address translation here. So we're going to do the same thing that we did last time. Going to ping the external router, get some traffic going. Okay. 203.0.113.20 again. Okay, so PC1's doing fine. We finally got a reply for PC2. Okay, so let's go back to R1 and check that traffic. All right, let's see here, show IP NAT translations. Oops. All right, so here we go. And as you can see, so we got client, well, PC1 right here and PC2 right here. They're using the same public IP address. However, they're using different port numbers. So that's allowing the multiple connections using the same public IP. And that is dynamic NAT with overload. And that about sums up the entire lesson, people. So thanks again for stopping by, and hope to see you in the next one.